The Souletics Way, a guide for sport and life, mental, physical, spiritual, technological, and strategic resource to help you dominate the challenges of life. I am here as a guide to assist you in
I was
overcoming
struggling in my
the
environment, so I
identifiable and
adapted,
unforeseen
exercised kindness,
circumstances that
used the
deter you
different
from your
strategies,
vision
studied
and
diligently,
purpose for life.
and when that
A
didn't work,
voice to
I
encourage you
changed scenery.
to reach and
Failure is
maintain
not an option.
peak performance
I will
in
adapt,
sport and
reinvent,
life
continue to
despite the
learn, but I won't
circumstances you
quit.
face.
I said, get up.
I want to talk about semiconductor design. This is a role that I spent years in technology um, doing. Uh, Prior to probably 2016, 90% of all computer chips in a desktop or laptop, I've either worked on or owned a chip. So this was something that I'm considered an expert in and that I know very well. And I think if you choose this career, it can transform your life and really jumpstart your technology career. Welcome, welcome, welcome. Today, I want to talk about a key technology skill that could generate thousands, hundreds of thousands, millions of dollars if you play it right. This is a semiconductor design is the foundation of the entire technology industry. And that's what I want to discuss today. I want to talk about semiconductor design and specifically job roles that you can do. They're called physical design engineer, math designer, those type of positions that show you how to design a computer chip. You are actually a designer. This is a key skill set and basically the foundation of the semiconductor industry. And just to give you an understanding of this, semiconductors are computer chips and they do exactly what they say. They conduct electricity. In semiconductor, the main material, silicon, is the main material used in semiconductor chips. And understanding that a semiconductor is stacked, it's like a building, layers upon layers that are stacked on each other. And these layers represent different types of materials that can conduct and allow electricity to flow. So, sand is the foundational element for semiconductor chips. And when sand is heated or melted, it solidifies. The result is what you call an ingot that is then sliced. Think about a very thick piece of metal that is round and it's not hollow, it's solid. A very thick piece of um, metal that is solid. And this ingot is used to create a wafer. It is then sliced in very thin slices to create what you call a semiconductor wafer. So you have silicon, which is sand, that is heated. So life comes into that when it is heated. Think about heat bringing life to the sand. You think about going and walking, putting your feet on sand, and how important that material is, and how healthy people. So semiconductors, silicon is used for many different, has many different uses. The third stage is photolithography. This is when oxidation is at photolithography or a photoresist. It's a layer that responds to light. So light is what's going to be used to carve. So you think about carving a stone, right? And you have the piece of metal that you hit on the stone, right? That allows you to carve it. Well, light is acts as that same has that same use where when you add this oxidative layer, the light will now respond to this photoresist based on the amount of light, the amount of photoresist, the amount of oxygen that's placed on the wafer. And this etching is the next stage where this etching material, or excuse me, not a material, etching is then used to actually draw or create the designs that you've created as a designer. So as a designer, look at semiconductor design as if you have a blueprint of a house and you take that blueprint of a house and you as a designer of a computer, you convert that blueprint of a house on a flat piece of paper to a 3D representation that you can see on the computer. It has all the wood, the flooring, the wiring. It is basically a real house on a computer. That's the same thing that you do as a physical designer, a semiconductor designer. You are designing a real computer chip on a computer is to make it manufacturable. And so this etching process is the part where you carve the layers to create the different sizes of electrical devices, electrical transistors. And the next stage is deposition and ion implantation. This is the portion where you are implanting an electrical property. Now, for the first time, you would say it's getting electricity. It becomes an electrical circuit at this point in time. So you have silicon, and you add heat to that silicon, which, and then you have photolithography, the etching, the deposition, and ion implantation. And you can see the stages up top: the wafer manufacturing, the oxidation, the etching, the ion implantation, and then next is you have the wiring process. Now, the wiring process is the part where you are connecting the different transistors. So think of that as now you're plugging the lawnmower, electrical lawnmower, or the vacuum cleaner into the wall. So now you have a vacuum cleaner that needs electricity, but when you plug it into the wall, that would be the wiring process. Now you're connecting these circuits together. And then the next stage is EDS stage. The EDS stage. This is a critically important stage. The EDS stage in semiconductor is the stage of electrical die sorting where you are actually testing the quality of the semiconductor. So you have a wafer, and a wafer could have hundreds, potentially thousands of chips on that wafer. And each chip, that's what's in your, one of those, that's what's in your laptop, your desktop, your phone. So at that point in time, you're testing the quality on one solid wafer of all the chips on this wafer. Look at a wafer as a pancake. And on this pancake, you have chocolate chips on top of the pancake. Hundreds of chocolate chips on top of one pancake. And you want to test, are all of these chocolate chips the same? Are they the same quality? Let me test them. Let me taste them all. And that's what the EDS is doing, is testing the quality of each chip on the pancake, of each chip on the wafer. Now the packaging is next. Now you slice each chip on the wafer into individual semiconductor chips so that they can be packaged, put in a package, and then sold, placed in phones and laptops and whatever technology device, Internet of Things device, and whatever device that they would be deemed appropriate. Now, this is fundamental. This process is the manufacturing process, and that all starts with a mass designer, a physical design engineer, someone who designs this chip that they're given a specification, like a schematic, much as you would see for a building, and they're able to transfer that paper schematic into a computer designed, representational, functional computer chip that's ready to be manufactured, that's used in this manufacturing process that I just talked about. Now, the next stage is talking about the entire semiconductor industry. And so when you look at the entire semiconductor industry, it's made up of many different components. You have the software side, which is, for example, if you have a laptop and you use PowerPoint to make presentations. So you have tools to make chips, and those tools are typically Cadence, Synopsys, Siemens. From those three tools, you could pretty much design any chipset that you want. It's an expensive, but you can design it. And then you have actually equipment, and there's several companies: Hitachi, ASML, Applied Materials, ASM. So those are the equipment that are in manufacturing facilities like that would be in an Intel. And then the raw materials, you have companies that provide raw materials. You have companies that don't design, they do not manufacture, but they're the middleman, the fabless design. Companies like they they may design they've designed IP. Companies like Nvidia, Broadcom, Marvell, Qualcomm, Apple. Those would be considered fabless designs where they design a chip and they have someone else manufacture it. And then you have just manufacturing facilities, companies like TSMC, Global Foundries, UMC. And then additionally, you have assembly, testing, and packaging, where they're putting all of these devices together. They're the packaging portion, Teradyne, Amcor. And then you have your integrated circuit manufacturers. Those are the the heavy hitters. The heavy hitters, the people like Intel, Samsung, Micron, Renesas, those companies. And so this is an overview of the semiconductor industry and a critical component of very highly sought out individuals, paid very well, a critical skill that you can learn, that is teachable, that you should at least take a look at and know about. If you're in technology, this industry or niche will always be needed. Will always be needed. Even in AI, you will still need people that understand how to look at and make transistor devices. That's it. I wanted to keep it short, but this is the semiconductor industry, how to make a computer chip, specifically roles in physical design and mask design. Thank you very much. I'm Damon Smith. This is Souletics. Use this information to advance your life, to improve your practical skill set. This industry generates billions of dollars and pays hundreds of thousands of dollars over the course of a career millions of dollars for this specific skill set. The main thing for you is to choose a very practical skill set that you could use to advance your life, your career, your family, and build your legacy. Welcome to the Souletics Way, a guide for sport and life. Mental, physical, spiritual, technological, and strategic resource to help you dominate the challenges of life. I am here as a guide to assist you in
I was
overcoming
struggling in my
the
environment, so I
identifiable and
adapted,
unforeseen
exercised kindness,
circumstances that
used a
deter you
different
from your
strategy,
vision
studied
and
diligently,
purpose for life.
and when that
A
didn't work,
voice to
I
encourage you
changed scenery.
to reach and
Failure is
maintain
not an option.
peak performance
I will
in
adapt,
sport
reinvent,
and life
continue to
despite the
learn, but I won't
circumstances you
quit.
face.
I said, get up.